Hi, so this is a review of a class test that we did for AP Computer Science Principles. What you're about to see are some questions from that test. They're screenshots of scans, so the quality is not great. So hopefully it's useful, but I'm just putting this together really quickly. Okay, so question 1. This is asking us to convert a binary number to a decimal number. So something to note is that when you see a number in parentheses with a subscript 2, that means binary. And when you see it with just saying base 10, or this could have been written as parentheses with a little 10, that means decimal. All right, so let me just switch this color right now. So because we have 4 digits in binary, let's just lay this out. 1, 2, 3, 4. Those numbers are 1, 0, and then 1, 1 going backwards. Now the thing with binary is that each position holds a value with base 2. So this position, let me just change this color. This position here holds a value of 1. So every digit that's here holds a value of 1. Every digit here holds a value of 2. Every digit here holds a value of 4. Every digit here holds a value of 8. Now, if you're interested in where this comes from, basically that 1 comes from 2 to the 0. And then we keep doubling it. So 1 times 2, 2 times 2, and then 4 times 2, and so on. So this is 2 to the 0 gives you 1. 2 to the 1 gives you 2. 2 squared gives you 4. And 2 to the third gives you the 8. So this stuff in orange at the top, if you remember it great, that tells you the value of each digit in this place. But even if you just remember 1, 2, 4, 8, then that's going to be enough. But the origin of the 1, 2, 4, 8 is the stuff above. So I'm switching to green right now to convert this. So basically if we have a digit of 1 holding a value of 1, that means that this is 1 amount of that 1. Over here we've got 0 amounts of the 2. So 0 times 2. Here we've got 1 amount holding a value of 4. And here we've got 1 amount holding a value of 8. So basically if we calculate all of these, 8, 4, 0, 1, and we add them all up, that's going to give us a total value. So in this case, that's going to be 12, plus 0 is 12, plus 1 is 13. So basically 1101 with a base 2 gives us a value of 13, which is our decimal number, which is our base 10. So 13 is the answer. Okay, number 2, let's take a quick look. So here we've got this the other way around right now. We've got 130 to base 10 and we're trying to convert it to hexadecimal. So when it was binary, we knew that this had a value of like 2 to the 0, 2 to the 1, 2 squared, and 2 to the third. So each of these would be 1, 2, 4, 8, and then we would find these values. With hex, it's not 2s, it's not base 2. So remember, binary is base 2, so that's why all of these are 2s. With hex, we're dealing with 16. So this is 16 to the 0, 16 to the 1, 16 to the 2, and so these values under these 16 to the 0 would be 1. Anything to the 0 power is 1. This would be 16, and this is 16 times 16, which is 256. And then we can put numbers underneath here. So just going to switch this color over. So we've been given 130, which is to the base 10, and we need to work kind of backwards to find what numbers go in here, what digits rather go in here, to give us a number to the base 16. What hex value here gives us 130 out. So when we think about 130, we've got to think, well, how many of these 16 squareds go inside 130? Well, 16 squared is 256. So how many 256s go inside 130? None. So you could just write a 0 there, or you could just ignore this whole thing. Okay, so we move on to the next one, which is 16 to the first, which holds a value of 16. So when we think about how many 16s go into the 130, well, 10 16s would be 160. So we're 30 too much, so we need to pretty much knock off 2 of these. So that would, instead of saying 10 times 16, let's say 8 times 16. Quick math over here. So this is going to give you 48 plus another 80, so that's going to give you 128. So we're close with this. So if that's 128, so it looks like we've got 8 of these. Now keep in mind what we did with the last question, and we can test this out. We've got 8 amounts of this 16. So just going backwards from the math we did over here, when we have 8 amounts of 16, if this gives us 128, now we also need to add something that gets us back to the 130. So we know we need to add 2 back. And so 16 to the 0 is 1. So a value of 1, we need that twice. So we basically went backwards. Instead of going to decimal, just like last question, we went from binary to decimal. Here we're going from decimal to hexadecimal. So it's almost as though we've got the answer in decimal first, and we have to work back to try and create, to try and construct that 130. So that would be 8, a digit of 8 in the 16's place, and then a digit of 2 in the 1's place. And keep in mind, these place values, instead of it being the units and the tens and the hundreds and the thousands, which would be the decimal system, this is the 1's and the 16's and the 256's and so on. So we've done all of the work. So basically 130 to the base 10 gives you a value of 82 in hexadecimal to the base 16, and that comes from right up here, these values right here. So 82 was your answer for question number 2. Okay, here's number 3. All right, so here it says convert the hexadecimal color A290F2 to RGB, and then here it's expecting 3 decimal values. So first thing to note is when we are dealing with hexadecimal colors, they usually come in like pairs of values here. So we have A2, which we have to figure out. We have 90, which we have to figure out, and we've got F2, which we have to figure out. Now, one thing to note about how hexadecimal works is that you start, instead of it just going from 0 to 9 or 0 to 10, we have some letters involved. So when we think about hexadecimal and the value of them, knowing that we go up to 16, hex meaning 16, we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we can't put, if we've got a couple of digits like A2 or 90, we can't put 10 on one of these spots. So what happens is it then goes to A, B, C, D. Now we've got to think, does it go to E or F? So if 0 to 9 gives us 10 digits, so this is 11, 12, 13, 14, 15, 16. So remember, it goes from 0 through F. Now each of these values is here, that 0 has a value of 0. So if you see a 0 here, it's worth 0 in decimal. Then this is 1 and 2, and every value is the same up to the 9th digit. But then A here is worth 10, and then this is 11, 12. Let me just undo that. The mouse isn't working too well. Okay, one more time. So A would be worth 10, B would be worth 11, C 12, 13, 14, and 15. And keep in mind, even though we got to 15 here, there are 16 digits because 0 is going to be one of them. So in this case where we have A2 in hex, that would be worth, in this, and keep in mind this is hexadecimal, So when we're dealing with hexadecimal, we're dealing with base 16. So keep in mind that because we're dealing with base 16, we're dealing with 16 to the 1 and 16 to 0, 16 to the 1. So this would be worth 1 and this would be worth 16. And we have a 2 in this place and we have an A over here, but that A is actually worth 10. The A is worth 10 because of our grid up here. So whenever we see a letter with hexadecimal, the letters are going to be from A through F only. And then we need to assign the corresponding value to that. So in this case, that there are 10 quantities, 10 amounts of that 16. So we're going to do 10 times the 16, and that gives us 160. So that's the value of that amount. And we're getting ready to add something else. We're getting ready to add 2 amounts of the 1. So that would give us the 2. So in this first case, which happens to be the red, the next group 90 is the green, and the next group is the blue, RGB. So the red has a value of 162. So we could even write that in here, 162. Now we've got to move on to the next one, which is the green. So keep in mind we have a 9 in the first and a 0 here. But that 0 is in the 16 to the 1's place, which carries a value of 1 for each digit. And this is that's 16 to 0's place, which carries a value of 1. This is 16 to the 1's place, which carries a value of 16. So to calculate this, we do the same again. 9 amounts of 16 plus 0 amounts of 1. So 9 times 16 would give you the 144 plus 0. So this in fact would be your green value, 144. And then the F2, so if we get this ready, the F carries a value of 15. So we're dealing with a 15 in the first spot and a 2 in the second spot. And keep in mind, these are the values. The 1 comes from 16 to the 0. This comes from 16 to the 1. So if we try and find the decimal value of this, we've got 15 amounts of that 16 plus 2 amounts of the 1. So 15 times 16 plus, so 15 times 16 would be 240. And then we are adding 2, so that would give you 242, and that would be your blue value. So 242 would go up here, 242, and that would be your answer. So your answer is this right here. Okay, next question. Number 4 says, what is the purpose of abstraction? So abstraction does a few things. There's a few keywords that hopefully you guys will remember, but abstraction does the following. It hides detail. It reduces or manages complexity. It sometimes aids, makes easier your workflow. In block-based languages like Snap, if we have to manage complexity by creating custom blocks, it makes it more efficient to use custom blocks, and then if you need to update, you just need to change one instance of that custom block, and then all of the places where it's being used is changed. So it increases efficiency. Okay, so that's generally what abstraction does. Okay, here's number 5. What is an operator? So operators are usually green blocks, but when we ask this question, we're not just talking about block-based languages, but we could put an example. So example, something that looks like this is a type of operator, blank plus blank. That's an operator. Also, operators might use greater than or less than. They might be some kind of a calculation or a predicate. So an operator is some type of a function or a piece of code that calculates. So let's just put it really generally. So a piece of code that uses a calculation or logic to report a result. That pretty much generally does it. At least that's a good enough definition early on in our curriculum right now. All right, question number 6. What is a conditional? So a conditional in terms of block-based languages is something like a if this then that, or an if else block. And even in non-block based languages you still have conditionals with if and else is in there. So a conditional is a piece of code that runs based on something being true or being false. So it runs, oh my gosh, my writing isn't too good right now. It runs really I should say the word dependent. It runs dependent on a condition being met. Okay, so again, generally this is okay definition at this early on in the curriculum. All right, number 7. Okay, a predicate. So in block-based languages, a predicate is, let me just move this up. Block-based language predicate may look like this, and the shape is a hexagon, and it could be something like blank, where you put a number is greater than 5. So sometimes this will be true and sometimes this will be false. So a predicate holds a value of true or false. And it usually uses math, calculation, logic, and also, for example, in the sense of what we've done so far with block-based languages and sprites on a screen, you can have a predicate that that senses if a character is touching the edge of a screen. So that can be a predicate where is touching something else is either true or false. Okay, number 8. In Snap, what is the stage? So in Snap, you have a few different areas. The stage itself is the place where you see the result of your code, including all sprites and movement. So that's it. Generally, again, don't need to be the most in-depth definitions, just a description. Okay, number 9. What is the scripting area? So the scripting area is where we drop the blocks, which is the same as saying construct the code, or scripts really. Okay, so that's good enough. Okay, number 10. In Snap, what are the sprites? So the sprites are really the graphical elements. So that could be characters. It could also be buttons. It could be the background. You could put background sprites. So that's pretty much good enough for this question. Okay, number 11. Okay, what are the blocks? So the blocks are pieces of code. For example, like move blank steps. So this here could be a piece of code, is one of the blocks, or a predicate block. Is this shape, or this shape is a reporter if it's curved. So this is a command block. This is a predicate. This is a reporter, which also operators are types of reporters, so they're going to look the same as well. Okay, number 12, block families. So these are groups of blocks with similar characteristics. Okay, so for example, all of the move blocks are talking about movement. All right, number 13. What is the purpose of a costume? So this is multiple looks for a single sprite. Okay, in computer science, what is a list? So whenever we're talking about lists, we must talk about items. So a list is a group of items. You could draw it, so in block-based languages, it looks like this, list, and then you have a bunch of items. Okay, so here we have 3 items. Okay, 15, what is a loop? So a loop is a repeating script. So there's several types. You could have a forever loop, a forever repeat. You could have a repeat, like let's say 10 times. You could have a for loop, which looks like for I equals 1 to 5. And what that does is it repeats it, and each time I is a variable that increments from 1 to 5, or you could even say from 10 to 7. And so this would put the value of I equals 10, and that would go through the loop, and then 9, and then 8, and then 7, and then it would stop. So these are 3 different types of repeating script, but you must know that a loop is a repeating script. Okay, so in this case, it says describe what the following will do. Let's just create a new thing here. So you must say when green flag is clicked. So only when the green flag is clicked, repeat 10 times, say hello. So what this is going to do is it's going to say hello, 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 and it's going to do this 10 times. But it's going to do it so fast without waiting that it might even seem as though it says it once, because there is no pause, there is no wait. So you must, I'm not going to write this whole thing out, but you must describe that here, that it says hello 10 times, not stopping, and it might just seem as though it says it once, and only when the green flag is clicked. All right, so let's just check. All right, so there were two question 15s here. So this is number 16. So when I receive any message, so basically when any message comes through, which is a broadcast, it's going to set a variable. It's going to set some variable equal to 5, and then it's going to say all of this for 2 seconds, then play a note. So we can't just keep referring to var anymore, because this is now 5. So we must do the math. 10 times 5, so all of this right here is worth 50. And 5 times 50, all of this now is worth 250. So what this is going to do is when it receives any message, we must write this, when it receives any message, it's going to set a variable to 5, it's going to say 250, it's going to say 250 for 2 seconds, and then it's going to play a note 60 for 0.5 beats. So you must explain all of this stuff fully. Okay, number 17. So when space key is pressed, so you must say it, when space key is pressed, it's going to say this, while I the first time is 1. So it's going to say 100 minus 1, well, it's not going to say 100 minus 1, it's just going to do the math and say it. It's going to say 99, and then wait 1 second. Now the next time this is going to run, this isn't going to be 1, it's going to be 2. So it's going to say 100 minus 2, but it's not going to say 100 minus 2. It's going to say the result of that. It's going to say 98. And then it's going to wait 1 second. So I'm not going to write the whole thing out, but you need to say that when space is pressed, all of this is going to happen. It's going to say 99, wait 1 second, say 98, and it's going to keep going until I is ... until I is 10. And so the last thing it's going to do is say 90, which is 100 minus 10, and then wait 1 second, and then it's going to end. So that would pretty much get you the points for number 17. Questions 18 through 22. Okay, so it says what is the value of the following blocks? What would they report if they were run? So as we see here, this is a predicate because of the shape of it. So this guy is trying to say that 5 is less than 3, which is false. And that's what this reports. It reports false. Here it's saying that A is less than 3. And in this case, because A is not a number, we can't compute this, and so A isn't less than 3, so this is also going to report false. Now this was saying it's a bonus, no worries if you don't know, just make an educated guess. So A isn't a number and B isn't a number, but because they are the same family of items, they're both letters. Here what in computer science this is doing is thinking incrementally, does A happen before B? And so in this case A is lower in the alphabet than B is, so this is going to report true. But again, this was a bonus question. Okay, for 21, it says join these two things. So this is going to be blue, dog, all one word. There is no gap. Okay, if you have a gap there and you write blue, dog, then this would be completely incorrect. So this is the answer. This is not the answer. Okay, length of, and then it has this text. So length of world would just report 5. Okay, question 23. So here it says join this thing and this thing. So straight away, length of IT, well, that has 2 letters, so that's going to be 2. Here it says length, letter 3 of house, so 1, 2, 3, that would be U. So joining U and 2, well, that's pretty much what this is saying, right? Join U and 2. So the answer would be U2. That's 23. Okay, 24. If the code ran, what would be the final number result? So it's setting the variable to 5. It's saying for I is 1 to 4, change variable by I. So the first time this runs, it's going to be 1. So if we change it by 1, it's going to become 6. So now the variable is 6. And then when this is 6 and it runs again, it's now, I is now going to be 2. So it's now going to be 6 plus 2, which gives us 8. Then when it runs again, I is going to be 3. So 8 plus 3 equals 11. And when it runs again, I is going to be 4. And this is the last time, because it's only going up until 4. So 11 plus 4 equals 15. And that's going to be your answer. That comes out at the end of this problem. Okay, question 25. What is the difference between a script variable and a regular variable? So the key thing here is that a script variable lives inside the script being run. The variable cannot be used elsewhere in the program. It can only be used in that script and then it dies at the end of it. Okay, question 26 through 30. So here we're told to write the value of the blocks for question 26 through 30. And it says that it's setting a variable shopping to this entire list. Now notice that this list has 1 item, 2 items, that's all living in the second item. So there's a list inside item 2 of the first list. This is the 3rd item, that's the 4th item. So when it says item 3 of shopping, item 3 would be 1, 2, 3, item 3 would be cheese. So that would be 26, cheese. Okay, the next one, item 2 of shopping. Well, this is item 1, so this is item 2. So item 2 would be a list containing soda and milk. So that's important. This is a list containing soda and milk. Okay, item 5 of shopping. 1, 2, 3, 4, 5. Well, that doesn't even exist, so that's just going to be blank. 29, item 1 of item 2 of shopping. So item 1 of item 2. So we need to think about item 2 of shopping, which is this guy. And item 1 of that is the first one, which is soda. Okay, number 30 says length of item 2 of item 2 of shopping. Well, item 2 of shopping is this. Item 2 of that is milk. So the length of milk is 4, because it has 4 letters. Okay, here's 31 through 33. Draw the default sprite icon pointing in the direction of -45. So this is important when we're dealing with sprite directions. When we think of north straight up, think of that as 0. And then going around, this is 90 degrees, 180 degrees, 270 degrees. And back up here, you could say 0 or you could say 360 degrees. And anything negative would turn us back this way for negative. So -45 would be kind of, this would be -90 towards 270. -45 would be up here. So this sprite would look something like this. It would be pointing in this direction. 90 degrees, it would be pointing in this direction. 270 would be the opposite, would be pointing in this direction. So those are the 3 positions of the sprites right there. Okay, and the last question was question 34. And here they just wanted you to list a bunch of them. So I can go through some. This is the move tool. This is the crop tool. This is the marquee tool. This is the magic wand. This is the eraser tool. This is the gradient tool. This is the heal tool. This is the text tool. This is the zoom or the magnify. What else? This here is the clone stamp tool. This is the fill or the bucket tool. This is the lasso tool. And you could go through, this is the red eye tool, but you only really needed to choose any 5 of these, and you can look into the others as well. this is the tool palette from Pixlr, and Photoshop is very, very similar. But this was a really quick recap of this quiz, so I hope it was useful.